Hi, everyone. I'm Aritra Mukherjee, software engineer and lead pipeline developer at Zebu Animation Studios. We are a studio from India. Today, I'm excited to take you through a journey that's both professionally and personally meaningful to me. We are bringing to life my country's first female superhero, a bold, culturally rooted character whose stories come from the very part of the country that I call home. It's a proud moment for all of us at Zebu. What makes this project even more special is our approach. The entire feature film, from assets to animation, lighting, and final rendering, is being done entirely inside of Unreal Engine. It is a challenge to attempt 80% of the pipeline steps completely inside Unreal Engine. Due to our talent depth and the lack of availability of skill and the awareness of the possibilities within Unreal Engine. To fill this depth, we inspire a holistic approach at Zebu by training our departments of assets and animation with bite-sized boot camps focused on exactly what our artists needed to learn. Let's take a look on how we did our assets. Our designers gave us a rough painted concept, but our CG team gave us something like this. And we still had to manage the clothing and make the final look of the character, all using Unreal Engine, and that's what we are going to see in a bit. Our assets workflow mainly involved use of Character Creator 4. Character Creator 4 allowed us to iterate and ideate the designs rapidly. Now, one thing that you have to make sure while using a third-party tool like this is your preferred choice of pre-visualization. Is it going to involve performance capture or not? If it's involving performance capture, different vendors and different softwares provide different rig setups, and you have to make sure that it aligns with the rigging choice of rig inside Unreal Engine. Because we were using the MetaHuman animator, the default character creator rig had to be adjusted, and for which we had used Maya's advanced skeletal system. And we had also created costumes and accessories and customized the MetaHuman, which, as you know, is the organic anatomy. But here we were trying to have custom characters. So one thing you have to make sure that you don't break the DNA file accidentally. So you have to preserve the hierarchy from the MetaHuman DNA file and make sure that you're adding your accessories or cloths on it. You can see on this picture that we have also adjusted the hand bone, the hand rig, to make sure it fits with the MetaHuman control grid. Now, once the final character is done, our rigging team does the control rigs, makes sure that everything is working fine, and also we plug in custom equations on the control rig. So one of the approaches that we took was to have a control rig per asset, per character, because every character required a specific equation for moving, like the shapes. Additional shapes were added on the shoulders, on the arms. To make sure all these shapes can be driven automatically with the control rig, we had to plug in different equations. This is an example of how we made the shoulder look flat with a non-natural anatomy, which is, not fitting the default MetaHuman behavior. So we wanted to override it. And what we did was add another extra blend shape to the shoulder and then drive it with custom equations right using the control rig. Again, it's very important to make sure your DNA file stays intact and the hierarchy names do not change when you are doing a round trip between Maya or Blender or your preferred choice of software. Before going to my next slide, I want to tell about and talk about a middleware product that we are building in-house at Zebu, which me and my team are developing. And this tool is called Rashomon. The name is also inspired from the Japanese film, which especially means that you can view different incidents with different meanings. You can associate different events with different meanings. And what Rashomon is is everything that an artist has dreamt of. So we'll quickly take a look of our assets workflow inside Zebu Animation. As an artist, you log into Rashomon, and as you sign in, you see all your tasks in one single page listed in category. A desktop widget pops up where you can start your timer for the tasks that you want to do. You go to today's task, see that you have a looked at assignment. Just click on launch task. And what this does is it connects to an agent on your workstation, pulls in all the files required for that specific task, bootstraps Unreal using custom C++ plugins, and launches Unreal with a turnaround of that character with default light setup. It also creates the sequencer with custom events, so it does a close-up of the character with bounding boxes. It also has created all the folders that you require and organized your files, created the material instances, and also connected the textures to the material instances. It has also created folders for level of detail textures. So you might be willing to have work with a different level of detail while you're working on animation task, and a different level of detail while you're doing your lighting task. We extensively develop these utility widgets, so you can, once your lighting is done, once your look development is done, you can come back on the widget, take a local render, select the render preset to render with, and hit on render local. Now, as it's rendering, what it's also doing is it is pulling in the data from the production management software, and it is creating a burn-in HUD, which has extreme level of information, starting from the frame rate of the render, starting from the start frame and the end frame, the number of vertices in the character. It goes through all these QCs, and you can see that the burn-in has been patched, and a PDF is also generated right before the publish step. So this PDF has every information that the clients need to look at. It tells you about the render time. It tells you about the choice of render. Was it rendered with Lumen? Was it rendered with path tracing? Which version of Unreal Engine has been used to render? And then you can hit publish local, and this would publish to our production site. Now, once publishing is completed, our supervisors can log back in to Rashomon, and they have a completely different view. They can see how many hours their artists are spending, open the media player, and also quickly compare all within one web framework. Now, Rashomon is a middleware between ShotGrid. So if you guys have been using ShotGrid, it sits in, which is now Flow Production Tracking. It sits in between Flow Production Tracking, pulls in all the data from Flow Production Tracking, and makes contextual views, which are only necessary for the artists and the supervisors and the finance teams and the production teams to see. We'll take a look at how we did our sets. Based on the design of the set elements, we identified what are the modular set pieces that we need to bring in Unreal Engine, and we could go off to Fab. Because this was completely being done in using Unreal Engine, we had to make an economic choice of not modeling the set elements from scratch. So we went on to searching on Fab, as well as some of the elements that we couldn't find had to be modeled with our modeling artist. So what you see here is once the modeling is done inside Unreal, once they have laid out the set elements in their necessary positions inside Unreal, they simply click publish, and the publish process automatically creates a job using deadline. And what this does is it sends off to a remote farm. Unreal Bootstraps takes an automated UV render. So it applies a checkerbox material, takes an automated UV render, and also assigns all the textures which were created with Substance and some of the textures which were not created with Substance because they were coming from Fab. So this is where U assets are beneficial because they do store the references of everything that you bring inside Unreal. And once the render is done, we can now move to the next downstream. So we used PCG for advanced controls, and we wanted our animators to be able to change the layout as and when required, because while the purpose of developing or creating a feature film from scratch inside Unreal is also to make sure that you have, like enough iterations, you have provided enough flexibility for your artists and animators to iterate over their design. Some of the elements were sourced from Fab, so we can use Easy Fog and Easy Rain, developed by William Fosher, who's one of our favorite. And you can take a look on that on Fab, scan this QR code, and it will take you to the Fab link. With the PCG, you can customize how your clusters are going to get made. What is the equation for scatter? You can define that. You can track the curve on the spline and decide what scatter algorithm you're going to use based on the curve that you have created on the spline. So you have this artistic abilities and controls, and you do not have to worry about how nature works. Coming in engine animation, we had a lot of choices, a lot of options to go about with. Our previs mainly constituted of performance capture. So for the body motion capture, because we had already created a rig which is ready for MetaHuman, we had used the body motion capture, and we had a Vicon motion capture facility available with us. And there were two options to go with. We had Xsense and we had Vicon, but we saw that there's a lot of, it's much better to go ahead with a Vicon facility if you have, because it allows multi-actor tracking as well. So if you want to shoot multiple people at the same time and also want very detailed finger animations, Vicon is the best. You can see it on Shogun and also see the live preview of the animation inside Unreal Engine before passing it downstream to the animation team. If a cleanup and refinement is needed, it could be done using Maya with advanced skeletal retarget, and then it could be ready for the cloud simulation, which we will see in a bit. For the facial motion capture, MetaHuman Animator is the best way to go, and you can also try MetaHuman Audio, which is AI driven and completely uses a machine learned model to create the facial animation right from the audio. So these are some of the initial tests that we did using Xsense, and you do not need a huge setup for this. You just need a webcam and a good camera for this, and directly see the output inside Unreal Engine. Audio. These are some of the initial tests that we did with MetaHuman Animator, and the problems stem from how you want to creatively control your look of the character. So here, Makui is, we are showing it as an age of 15. She's a young kid, and the lower mouth should not be affected that much by gravity because of her age. And that's why we had to again customize the facial control rig slightly, plug it with equations, so that when you're capturing it with the MetaHuman Animator, when they retarget it back to Unreal, there are constraints involved within the control rig equations, so that you can control how much the mouth should be open while she's talking, whether the teeth should be inside. And these are challenges that you have to overcome when you're doing a custom control rig inside of Unreal Engine. Once the Vicon motion performance capture files are ready, and we have the exported FBX from Shogun. We further move it to a facility of artists who now retarget this particular animation to the MetaHuman control rig. It simplifies the cleanup process and also adding an extra layer of refinement just before it reaches to the animation team. This is live from the shoot. Our director, Mr. Virendra Patil, is directing one of the shots. So this is where the facility that we used gave us advantage of where we could have multiple actors and we could, see one shot completely live and seamlessly transfer the data inside of Unreal Engine. Unreal's new animation framework provides a lot of tools, and it's also comparable to Maya's in-house tools, and it's slowly becoming a player there. And our animators love to use these tools. And with the boot camps that we had created, we were able to train the animation team. We did a 1:1 translation of what they know in Maya and what they need to do in Unreal to achieve that effect. So with the version of engine, Unreal 5.5, we had the ability to use constraints, curve editor, animation layers, and pose library. This is a utility widget that helps the animators pull in the files. They can simply click on the shot they're assigned to, click on open, and all the files will be synced to the local and within the content directory and open the shot which they can start animating on. Once the shot is pulled, they can use constraints. One of the key important things that you need to make sure while using constraints inside of Unreal Engine is to make sure that you bake the constraints before it passes downstream. Before the publish process, you have to make sure that it's baked as an animation sequence. So some of these QCs we have already plugged in within our utility widgets. So right before publish, it does a quick check on the sequencer where everything is an animation track and no keys are lying around freely. Our animators told that they found it very familiar to use the curve editor because it has all the key features necessary for doing animation right within Unreal Engine. One of the important things here while doing animation inside of Unreal using Engine was the layers. You do not want other animators to destroy. If there's a reshuffling of the assignments, you do not want them to damage or destroy their work. So we use animation layers to slowly tweak and transfer some of the animation only when it is required. So animation layers also allow you to edit the performance capture animation, which is coming in raw inside Unreal Engine, so which is a great feature, and this helped us a lot by keeping the pipeline non-destructive. Pose library is a tool inside of Unreal Engine. You can create per character poses. You can define what will be the poses for like their hands, their legs, and how's the body going to look like for some of the repeating shots. This creates an ecosystem for other animators inside who are on your storage using the same Unreal Engine. They will have access to the same poses and they can use it as a library for them when they are animating inside Unreal Engine. So once it is done, our artists simply open back the widget. They open the shot they were working on, select the render preset, and hit on Publish Local. So what this will do is it will take a render of the shot. So one of the important things to note here is when pulling in the files, we make sure that the project settings of Unreal Engine are different. For lighting, it is different. For animation, it is different because you do not want your animators to have like an RTX 4090 because their hardware requirements are low. So we had to make sure that we create a stream of the engine. If you're using Perforce, you can create a stream of your engine for the animation tasks specifically, which will have lower graphical requirement. It could use Lumen with no hardware ray tracing, and that can be used for animation. Moving on to simulation, we had a couple of options to go about with, but we went ahead with Bifrost, which was simple to program and also export it as an Alembic and bring it back as a geometry cache inside Unreal. Now, while using Alembic with animation and making sure that the Alembic follows the FBX animation properly, you have to make sure that your sequencer is locked and it is on the right frame rate. So there is, because the Alembic doesn't have interpolation, and the FBX has interpolation. So you need to make sure there's a lock on your sequencer. Moving on to here, things get a bit difficult, and we had to make like economic choices of whether we need to go with Unreal Physics, which is the Spring system, or whether to move ahead with XGen. Now, XGen will obviously provide you a higher fidelity on the hair simulation, but for some of the shots which are not close-up, we found that the Unreal Spring system is a much better option, because you do not want to, spend extra staff days on creating that specific groom simulation. This is how it looks, taking the show from animatic to pre-visualization, through animation, and what it looks in lighting. While doing the entire project inside of Unreal Engine, it is important to note that we keep a parallel pipeline, so we enable the teams, the departments which are working on the show, to be able to update anything that they require at any stage. So if there is a rig change, how is it going to affect your animation downstream? If there is a change in the animation, how is it going to affect your lighting downstream? So it is very important to categorize the data. So which we will see in lighting, that we had created containers of lighting levels inside Unreal. So if there is an animation change, if there is a sequencer change, we only publish the things that we require from specific departments. So if animation is publishing, they only publish the sequencer and the level which is containing the set. But when lighting is published, they only publish the lighting level. And when we launch it for rendering, we only launch the persistent level, which contains all of them together, so that we do not miss out on any information. For in-engine lighting, our directors wanted to go ahead with a neo-noir style of lighting. And our team last year has also delivered Piece by Piece, which is Pharrell Williams' biopic, and happens to be the first Unreal path traced feature film. So everything end-to-end was rendered with a path tracer inside of Unreal Engine. So we went ahead with path tracer again with this project, because it provides cinematic realism. The depth of field is cinematic, and it confines to the traditional lighting requirements of the directive. We also use the movie render graph for one simple reason, and which we will see in a bit, but here's how our lighting assignment starts. As a supervisor, you can just log back in Rashomon, assign the lighting task to an artist, select the start date and the end date. Just put in yourself as a supervisor and save it. And the artist now logs back into their dashboard and see their tasks on today's task list. They can again click on Launch Task, and this will bootstrap Unreal with a short syncs tool. And what this is doing is it is getting all the data respectively from different departments. So it's getting the updated rig, it is getting the updated look development, which is all single blueprints with different, each as contained in a different folder. And it's pulling in all the files, and it also zooms in with the camera cut track. And the artist here just needs to like the shot. Doing these kind of automation helped us reduce the technical barrier for uh, our artists who are coming from a more traditional backgrounds. It is also important to note that our staffing is in a way that our lighting artists are, like we hire lighting artists right from school, right, graduates, so they don't have to unlearn a lot, and they can easily get into Unreal Engine lighting with simple bootcamp trainings. Once the lighting is done, they can again choose to publish it. And what this process does, it's they select the render preset, and this creates a job on Deadline. We are using Deadline as our render management tool. And once this job is created in Deadline, we also have a tool which we have created, which lets you split the shot and create chunks right from within Deadline, which is not available by default. So once the job is created, you can now split the same sequencer into multiple smaller chunks, and each chunk will get rendered in a different system while also maintaining consistency of the render. Because we were using path tracing, and this is a much more preferred way of rendering in path tracing when it comes to traditional pipelines, we had to make sure we have these toolkits at our disposal, with each frame taking about 20 minutes to render. So this is how our lighting inside Unreal looks. Artists only focus on adding or tweaking the lights which comes from the approved set. So on the left side, you can see what the lighting looks when it comes from the set publish. And on the right side, you can see our artist doing a live lighting, and we have achieved 24 frames per second live on the editor with the path tracing checked on. We were able to do this by compressing the textures, by taking care of the polycount budgets and everything required at every little stage. And this is only possible if you have a lot of QC tools which do this for you while publishing. So while publishing modeling, we do a QC check of whether it's meeting our polycount budget. And also, while publishing textures, we make sure that we publish two level of details for the textures, one for lighting and one for animation. So the same file can load properly on a 3070, while the same file with the required amount of fidelity can load on a lighting system, which is an RTX 4090. So with our choice of path tracing, we made slight changes to how we use path tracing this year with Wingstar. With the movie render graph and with a very newly added render feature, especially which is going to help you for groom rendering. When you're rendering groom, you require a lot of temporal stability. Otherwise, you will end up with ghosting. And this temporal stability can be achieved with NFOR denoiser, which is available from Unreal 5.5. The NFOR denoiser can only be used from the movie render graph. While using the NFOR denoiser, which is a much more spatially stable and temporally stable denoiser compared to the built-in denoiser inside Unreal, you might end up with a lot of, max path intensity fireflies. So the fireflies are gone with an FOR. But you might end up with certain, path trace trails, causing the light to bounce a lot more, and you can end up with a bright dot. Those can be reduced with the max path intensity, which is as shown on this on the slide. And you have to make sure your denoiser type is temporal, and also select the frame count, the number of frames that will be calculated during the spatial sampling. We have built render management tools which are completely written in Python and a bit of C++ blueprints as well. So we make all these editor utility widgets and heavily depend on Python scripting for the automation. Unreal Engine has an amazing API, Python API, which our traditional pipeline developers who are creating tools for Maya, who have been creating tools for Houdini, can take a look at and automate this completely inside Unreal. So deadline render management tools take care of publishing and creating a job with a unique ID. On deadline, we have a manifest system. The manifest system collects all the data that is required to pull from Perforce. It logs in the repo paths. If you're using a NAS server, it would store in the NAS locations of your assets. It would create a manifest with files those are required to render inside Unreal Engine. For example, your assets, your levels, and everything which is linked to certain, like items within Unreal Engine. For example, the textures, the materials, and everything. All of it is a manifest, which we call as the job descriptor. So with this job descriptor, a command line job gets pushed to deadline, and all the files required for rendering are also passed on to the edge server. Once the edge server sync completes, our render node location, which we have like 4 locations with each location containing about 20 nodes to render, 20 RTX 4090s to render. Once the render is done, it relocates all the assets back, publishes the content, and also publishes the MOV or the required file type to our production site. This is an example of what happens in the workstation. Unreal automatically bootstrap. You can see the command line bootstrapper collecting all the assets and starting a render. And while it does this, once it gets the first frame of render, it also notifies the artist on the preferred choice of communication. It could be Slack, it could be Discord. You can use their webhooks to send the EXR data, compress the EXR data to a PNG, and send it as a notification so they can take a look on if something is going wrong, because this completely happens without them knowing. So what is the benefit of doing this? The benefit of pushing and offloading some of the software intensive resources of Unreal Engine, like importing of the files, importing of the Groom cache, importing of Alembics, which sometimes, depending on the shot length, can take you hours, now happen without the artist having to look at the monitor with a loading bar. So the loading bar is gone for them, and they can start on their next assignment. This way, we also bring down the technical barriers, because your pipeline tools now take control of which settings you're going to import the Alembic with, which settings you're going to apply for your FBX and skeletal meshes. They do not need to do the study that the pipeline team needs to do. Again, thank you, Epic, for inviting me. At this point, I'd like to take any question.
Thank you for the talk. So how long it took for you to build this webline? How many developer to maintain this webline?
Yeah, so we had been, we started off 2019 with real-time engines completely, using Unreal Engine and dedicated to use Unreal Engine for our projects. And we delivered Lego Dreams as our first show, which is available on Netflix, which was a 40 episode show with 2 seasons of Lego Dreams. And we also delivered the first path traced feature film, rendered with the path tracer in Unreal Engine. So we had been developing our pipeline, with around 5 years. But Rashomon comes in as a new development, which is being done this year, and we're pretty excited to use it on tour.
Cool. Do we have any other questions? Yes.
Thank you so much for the talk. Quick question in terms of the rigging aspect of the characters. you mentioned that you had to go in and customize the rig, and there were rigging artists for the control rig specifically. Why did you not consider using like the CC4 plugin that the Realusion released themselves for their characters rather than like making the control rig yourselves?
Yeah, we did use the default CC4 plugin to transfer it to Unreal Engine, but for some of the characters, because this is an inorganic character, I mean, which we needed, we needed to creatively change the anatomy of the character because it doesn't conform to what the organic metahuman is. So we wanted to add shapes. We wanted to, additional blend shape triggers on the shoulder and in between shape on the arm. So when the character is, folding the arm, we wanted the shapes to change there. So to add more, give control, we used it. We just checked whether this character is working with the default character CC4 export. If it is not, we take it through Blender, and then Blender also has a Character Creator 4 plugin which does a direct export for Unreal Engine as well. So we just quickly changed the shapes and brought it back to Unreal Engine. The only thing you have to make sure that you do not end up tweaking the hierarchy, because you might be headbanging after that, because once that is lost, the control rig won't connect back. And if it is lost, you can actually write a construction script and make sure all the bones and all the new bones are added to the processing of those 10 controllers.
Do we have any other questions?
Yes.
I'm coming over.
Hi, with your metahuman facial animation capture, did you do tests with like mono cameras or stereo cameras and also high-speed cameras to find which gave the most precise facial capture data?
Sure. Not with the stereo cameras, but we did extensive tests for the metahuman animator facials, because it was very difficult to translate the data accurately, because you also need to make sure it creatively fits the show's requirement. As I was saying that, we had to make Mapri look young, and some of the shapes like teeth and the areas of the cheeks won't directly transfer because it's slightly cartoony compared to what the actual metahuman is. So we did these tests early, and we identified what equations we need to plug into a separate control rig. So that's why we went ahead with creating a control rig per asset. So Mapui had a different control rig to it, and then there's one character, Mapui's father, he had a different control rig for it.
Do we have any other questions? Yes.
Did you do any post-process after rendering?
Oh, yeah. Some of the shots, very few actually, 10 to 15% of the shots where slight effects adjustments were required were actually taken to Nuke. The EXRs were actually taken to Nuke. And the color grading was also done in Nuke. So, but we want to avoid that. It's actually like you can work it out as a balance. We just have 2 compositors in our team, and you can just push off 20% of the shots to them. And we want to make sure everything comes out of Unreal as a fresh bake.
Okay, thank you. And one more question. Are you waiting for the passes in Unreal Engine in the future?
Sorry.
Are you waiting for passes for Unreal Engine in the future?
Yes. So when we are giving off the renders to our comp team, we actually use the movie render graph to render some of the beauty passes and the specular passes mostly. And depending on the requirement, if they want to add like an effects, we would also render the alpha of the characters. So it depends on. So we had designed our tool in a way that you can mark a certain render for a pass, and you can the certain movie render graph will be used to render that kind of So if they select on the drop down beauty pass, the movie render graph with a beauty pass, like a selection would get used for that render, and those renders will come up as a new version.
But it's separate renders, as I understand. Yeah.
It's a separate render.
But yeah, I mean, do you want one render, yeah, with different passes in the
Yeah.
future? I mean, like functionality in Unreal Engine.
Yeah. So you can do that with MRQ again. You can, while rendering, you can render out multiple passes together. But we also want to make sure some of the shots which were using PCG, like there's a forest shot which is rendering like millions of trees together. It might crash sometimes. So you want to see the budget for the render and then advise the artists not to render it, whether to render it separately or whether to render it together.
Thank you.